Now if you look at the force or the vector, which is 12, yes, it has got it's a horizontal along the x-axis, therefore you can't have any components on the y-axis. So you will have x along the x-axis, there will be 12, but along the y there will be 0. Can you see that? Okay, let's start from there. Now let's continue with the other force, which is the vertical one, which is the last one listed there. The vertical one now along the y-axis, size 10. Now that is only along the y-axis, nothing along the x-axis. Yes, therefore there will be 10 on the y-axis and the 0 on the x-axis. Okay, so now looking at force 20, that can be split into two forces, P and Q, which are at right angles to one another. Force P is at 45 degrees to 20, and Q is vertical to P, or at right angles to P. So cos 45 is equal to P over 20. So when you find out the ratio for cos 45, is that right? Because 0.707 equals P on 20. When I cross multiply, P is equal to 20 times 0.707, which is equal to 14. Is that right? Cos 45 being 0.707, which is equal to P on 20. P is equal to 20 times 0.707, which is 14. So what is on x-axis will be 14, and the y, the second component Q, which will be the same because 45 degrees that too, and so equilateral triangle, therefore is 14. Similarly, doing for force 30, cos 65 is equal to P over 30 cos 65, so P is equal to cos 65 times 30. Cos 65 is 0.4. How much was that? Point? So the answer for that would be 12.67. So when you add all the forces on the x-axis, they add up to 28.67 in a x-axis going left to right, and the forces on the y-axis is add up to 52 going from top to bottom to top, and then the resultant will be, using Pythagoras theorem, will be 59.4, and the angle with the x-axis will be tan inverse 52 divided by 28.67, which is equal to 61.1 degrees.